1. Today I want to discuss types of hybridization part 2. Last class we already discussed the sp hybridization, their examples and one formation. In this session we'll discuss the sp2 hybridization. sp2 hybridization. Okay, sp2 hybridization. Let's see how to formation of sp2 hybridization and the definition. Let's see the intermixing of one s orbital plus two p orbitals to form three sp2 hybridized orbitals are formed. I will repeat again. The 1s orbital is combined or intermixing with two p orbitals to form new set of three sp2 hybridization orbitals are formed. Let's see the structure also in this, right? See the structure of s orbital like this. Spherical is one s orbital is combined with two p orbitals. Actually the shape of the p orbital is the dumbbell, no, right? That is the first dumbbell and the second dumbbell, two dumbbells. So one px and py. So when these two combine, one s and one two p orbitals to form a new set of hybridizer orbitals are formed. That is a structure like this we can draw. Totally three hybridized orbitals. Like this is one sp2, this is a second sp2, and this is third sp2. Totally three sp2 hybridized orbitals are formed here, right? It's between the angle is 120 degrees, 120 degrees between sp2 and sp2 and sp2 in 3. Each sp2 120 degrees angle is there. That is a trigonal planar shape. Trigonal planar shape. Right in the each s character and p character, that is a 66.66% of p character plus 33.33% of s character, right? So let's see the examples of sp2 hybridization. That is a BCl3, boron trichloride, sulfur dioxide, SO2, sulfur trioxide, right? And C2H4, C2H4 in this name ethylene. So and benzene C6H6. Some more examples are there, right? Let's see the formation of BCl3, that compound formation of sp3 hybridization. BCl3 formation. Let's see how to form of BCl3 based on the hybridization. Let's see. So here the central atom is a boron, is a central atom. That's atomic number is B. Atomic number is 5. The electronic configuration, that ground state of electronic configuration is 1s2, 2s2, 2p1, right? So when you write the orbital form, you can draw like this orbital form. In this 2s orbital having 2 electrons, the 2 electrons like indicate like this, and this one more electron. An excited electronic configuration is that electron shifted from here to here, that's way. So the orbital form is, we can draw like this, right? Here one electron shifted from 2s to 2p. Why that? So here one s orbital and 2p orbitals. That formation is sp2 hybridization. Already know the structure of sp2 hybridization structure. Draw like this, no, right? See here, I want to draw again that sp2 of hybridization of a pr boron atom. You can draw like this, right? So this is a sp2 hybridization of boron, right? Boron atom. This is a boron atom. So in this boron atom having 3 unpair of electrons, 1 2 3. The 3 unpair electrons like indicate like this. So in this boron atom is required to stable, it combined with 3 chlorine atoms. It require ability of that 3 chlorine atoms. That's 3 chlorine atoms. Actually, the chlorine atomic number is 17. No, that is electronic configuration 1s2, 2s2, 2p6, and 3s2, 3p5. No, 3s2, 3p5. This is a valence shell. It has a orbital form. We can write like this: 2 electrons and 1, 2, 3, 4, 5. Right? It is a 1 unpair of neutron remaining are pair. Is there one unpair of the participates the 3 boron atoms? Right? 3 chlorine atoms is required to formation of the PCl3 formation, right? 3 chlorine atoms. Actually, in this one unpair of neutron, which orbit? This is a 2px, no, 3px, 3px and 3py and 3pz, 3pz, right? Orbital form that 3pz orbitals, 3pz orbitals. So this is a 3pz orbital. This has one unpair of neutron. So when these combined, these one is boron atom and 3 chlorine atoms to form new structure is formed. That is a formation like the right. The 3 chlorine atoms another chlorine atom and third chlorine atom. 3 chlorine atoms. 3 chlorine atoms. This is the chlorine atom. Second chlorine. This is third chlorine atom. 3 chlorine atoms. So this is a boron atom. The boron atom is combined with 3 chlorine atoms. It between the bonds is a directly attached axial overlapping. That is sigma bond. Here formation 1 sigma bond. Totally 3 sigma bonds are formed. So between the angle is, you can draw like this. Boron is combined with 3 chlorine atoms. Chlorine, chlorine, chlorine. So between the angle is 120 degrees. The shape is a trigonal planar shape. Trigonal planar shape. Right? Thank you.